Welcome back. In this lesson, we're gonna follow up on some basic stuffs on in Python. So we're going to introduce some concept to make the structure of the nodes and basically whatever kind of mm, custom library you want to write. So we're going to make it a bit more consistent and reusable throughout the different scripts. So we're going to introduce the definitions. So what is a function, how to implement a function. We're going to see how to implement a function within the Dynamo script or how to implement a function outside Dynamo environment, and then how to link these functions inside Dynamo to be reusable in different scripts. So in this way, you'll be able to create your own library, and using this library through different projects, you can always implement new functionalities and then reuse this functionality within other scripts. We're going to introduce as well the concept of class. What is a class? So this will help us to understand the logic behind object-oriented programming, and this will be the first step to go to the next level of development, which will be to interact with the Revit API. So Revit APIs are based on object-oriented paradigm. So the way to understand, I mean, if we want to fully understand how to interact with the API, we first need to understand what is a class and how we can create a class and how we can use a class within our scripts. But we will get there. So we can start from a very basic concept of how to implement a function. So let's always start with very simple example. So I usually use the range function, which is pretty simple. So the range function has a start, end, and a step, and we can use some number slider here. So the number slider is the start, and then we copy paste from 1 to value of ends, and we can have a number slider here which will be the step. So we can connect this, and then we can see what's the output. So as expected, we have 991 numbers. Probably it's too much. We can reduce a bit and run again. So it's pretty much very easy, and I'm sure you are already familiar with the way of creating ranges. So I'm not going to focus on this. The idea is to replicate the same tool, the same node using Python, not because we can't use the range, but it's just a very easy example to start with. So let's open our Python script, and then we need exactly 3 inputs. So the first input will be the start, the second input will be ends, and the third input will be step. So using this example, I'll be able to show you some pretty interesting stuff within the Python script. So let's go under edit. As we already know, we have a pre set up template for the Python script. And by the way, I will show you how to customize this template, which is something very interesting and is a new functionality that is available from Dynamo 2.0. So you can create your custom template, and you don't have every time to re-implement and re-import all the libraries that you need for your script, or you have to cancel, for example, delete the functionalities or libraries that you don't need in your scripts. So for now, we can just get rid of this part, which we don't really need. And we can start to read our input. So remember from the previous lesson, I can name a variable, and then this will be equal to in 0. The second one will be end, and this will be equal to in 1, and the third one will be step, which will be equal to in 2. And for now, out can be just 0. So remember that is a very good behavior to always comment your script. So this is the inputs, and we can call this outputs. So, and here we can just place some code. So you can customize your template to have all these comments pre-filled for you, plus other comments. For example, on the top, I usually write the name of the script, and then you can have some kind of description and the author of this one, and then maybe you can have some guidelines. So in this way, you will keep your documentation within the script, which is a very good a good way to maintain your scripts, because yeah, you can always create a one-page Word document that you can share through SharePoint, or you can share using some common environment. But is usually much better to have the documentation within your script. So whenever you open the script, you already have all the information you need, all the scripts that you are using, all the libraries that you are using. If you're using some custom node coming from some third-party package, and so on. So I usually spend a bit of time just writing the right comments, which is always good for someone that has to take over your script or your or whatever workflow you are working on. So this one is the libraries, or whatever you want to call it. So for this specific script, we have 3 inputs. The code will be just, as you can imagine, is a loop, and we have 2 kinds of loop. So if we go under Google and we go under for loop in Python, so you can always check the wiki pages. The documentation is very well explained. So if you don't remember how to use some specific syntax, you can always Google it. It's pretty quick, and Python is very well documented everywhere because it's used everywhere. So the for loop is pretty simple. It has a for, then it has a variable, which is the local variable for the loop, and then we have a range. So the range can be almost anything actually, but usually is a range of numbers. So you have a starting number and you have an end number, and usually the for is ending one number before the final real number. So if you have this X range, the first time is looping through 0, the second time is 1, the third time is 2, and the fourth time is 3, and it ends the loop. We have another kind of loop, which is the while loop, and the while loop is slightly different from the for loop, because the for loop has a specific number of iteration you are going through, and you are going through this iteration every time. So there are ways to stop the loop, but actually if you don't have any code breaking the loop, you go through all the steps within the range. And actually you know exactly how many steps you have from the beginning, because you are choosing the range from the beginning. The difference with the while loop is that the while loop is going through iteration until it finds a specific statement. So for example, if you check this example here, you have a variable which is equal to 1, is actually equal to 1, and until the loop is true, so while the loop is true, we print something which is the to infinite and beyond, we're getting close on blah blah blah, and x is every time we loop through this while, we increment by 1 the loop. So this is actually not a good way to use the while, because this loop is going to infinity, and this will just break everything, because Dynamo or whatever tool you are using for writing the scripts will just go into an infinite loop and will just go and freeze your machine. So there should be always a way out from the while. So if you use a while, you have to find a way that there should be any kind of statement that at a certain point will just exit the while. So we stay inside the while until something happens. So for example, we can go into the while loop while, for example, the x value is less than 100, or while the x value is greater than 100, for example. So we stay inside the loop until the statement is true. Whenever the statement is false, we get out from the loop. But we don't know exactly from the beginning how many times we are going to cycle through the loop. And the difference between the while and the for is just this. So in the for loop, we exactly know how many steps we have. In the while, we don't know it from the beginning. But be careful with the while loop, because the while loop, the difference between the while loop and the for loop is that the for loop doesn't go to infinity, because we always have a specific number, a specific range of steps, whereas the while loop can go to infinity and can break your script, and actually will just freeze Dynamo or Revit or whatever is running the script. So be always careful with that. So let's go with Python now, and let's try to use this one. So the for loop implementation is pretty simple, because we use a for, and we just said we want to use a local variable. We can call this x, and then we define the range, which will be between the start and the end. And while we are inside the for loop, we just create a new list, which will be an empty list. So we can call this range, for example, which is, as you can remember, how we can instantiate a new array, an empty array, is using these brackets, these square brackets, open and close. And then we can just say that range dot add. So we add a new value to this range, saying that this is equal to x. So we add x to the range. So the first time will be the start value, and then we add to x is equal plus the step. So the second time will be, I don't know, 2 or 2.1 or 3, whatever. It depends on the step. And then we go on the next step, and we add again x to the range, and then we increment by the step, and we go back to the beginning. So we go inside, we iterate inside the for loop until we reach the end, but we exactly know when we start and when we finish this for loop. So at the end of the script, after the loop, we can print out the range here, and we can save it. So if we run now, the script, of course, is waiting for the input first of all, but then we can see that there is an operation fade. So unexpected token new line is usually one type of error and is a syntax error, and 99.9% of the times means that you are missing something in an if statement or in a for statement, and this one is the semicolon. So at each time you initiate a new loop, or you initiate a new if statement, or you will see you initiate any kind of functions, you need to use the semicolon. And the next line will just use a tab value. I did it without saying it, but you need to press the tab because you have to go one indentation line inside, and then whatever is under this one before exit the loop should be always aligned to the same. So if I try to move this one back and then press, for example, just space and not the tab in this way, and I can save the change now. I can run again this one, and we can see that there is another error, which is unindent, does not match any outer indentation level. So that means there is some missing indentation, and that is pretty quickly understandable because I use the space bar instead of using the tab. So this is a common error, especially if you have a Word file and you try to copy and paste from a Word document inside a Python script, because the Word document has some kind of I don't know, style applied to the text, and sometimes it can't recognize exactly a clean text, like, for example, the Notepad can do. So my suggestion is that if you have a Word, or you're copying from a document, a Word document that can be, I don't know, and hands out from AU, Autodesk University, or any website you find, the suggestion is just copy it from there, paste into a Notepad environment, then adjust all the indentation as it goes, and then copy that code into the Python script. And then in this way, you probably reduce a lot the number of syntax error that you can find. As I said, I usually use the Notepad++ as an environment instead of the common Notepad. So yeah, so this one will do more or less the trick. So let's save now and run. And of course, there's no list of element here, and there's an error on line 19, which is saying that we don't really have this start and end value. So let's save this one. We can connect now this value from here to here, from here to here, and from here to here, and then we can run the script. It still has some error here, so let me see what's going on. So start is in 1, end is in 2, and step is in 2, correct? So the range is right. So for X in range, start to end, it should work. It's probably plus equal, sorry. Oops. And save and run. Why, if I go from 0 to 5, So there's probably some error with should be fine. So there's probably some error here. Oh yeah. So there's another error here. That's the good thing of doing stuffs on live, because you can actually understand the type of errors. So as you can see here, I'm using range as a name for a variable, which is a restricted name because it's also a name used by Python to identify a range for a for loop. So I can't really use range as a name for a variable, like I can't use import, for example, as a name for a variable. So I can say that this one is a range array, for example. Then I can copy this and paste here. And this one is range array. So you probably found out before me this error, but it's good to have a go. So I was expecting this one really as an error, because I wanted to explain to you the way the casting of types is working. So as I said, the for loop is actually expecting some kind of integer number, because it wants to run for an integer number of steps. So if you want to use float numbers like we are actually using in this specific one, the for loop is not really the best way to do it. And that's why we have also the while that we will see in a couple of minutes. So if we want to use the for loop in this case, we need to use an integer number, which will then guide this one as an integer. So we can go from 1 to 10, and the step will be 2. And as you can see now, it's working because we are providing integer value and not float values. So this will be the real output. So if I change this one, we'll change the number of steps. Let's go with this, let's say 100, and then run. So let's see how it works. So the first time we enter the loop, it's going to be 1, and it's right. The second time, and then we add 5, which will be 1 plus 5 will be 6. So the second number will be, actually should be 6. Let me see why it's not working. Plus step is, yeah. I don't really understand why it's not working today. So let's try to change this one. X is equal to X plus the step. And this one is not really working. It doesn't matter how much I implement this one, and I don't really understand why it's not working. So from start to end, and X is equal to X plus step, which is right, and the second time X will be exactly oh yeah. We don't exactly need this So this will be start, and start is equal start plus step, and now it's right. So sorry for that. So the idea is that I was just adding to x the step value, but what is actually driving the number is this start value. So the first time start is 1, and then we write start into the array. Then the second time we add the step to start, and then the second time will be 1 plus 8, which is 9, and then we overwrite the start value, and then the next time will be 9 plus 8, and blah blah blah. So if we reduce this one and we rerun the script, it's gonna work now. So it doesn't really matter the last number, because this is going to be done for 70 times. So this one will just give us the number of elements and not the final number. So the number of iterations we want, and this one will be the increment between the different numbers. So it's as you can see, is not the ideal way of writing this range, because the range is behaving slightly differently from the one we are using here. So to be able to do that, I will just copy this one, and what I will do, I will connect now this slider here. And instead of the for, I'll just use a while loop. So let me remove this one. The input will be the same, and I will just say that while the value x, which, as you remember from the documentation, we initiate the value before entering the loop. So while the x value is at the beginning is start, so while the x value is less or equal to end, semicolon, we go new line and we hit the tab. So until x is greater than end, so until x is, so while x is less or equal, we add range array dot add x, and then we do x is plus equal step. So there is actually a time when this while will stop, and is when x reaches the value of end. So we're pretty sure this is not going to an infinite loop. And that is exactly what we were expecting as a result. So if we move this one, they will just behave the same way. So we can do exactly the same thing using a Python script. So what the range is actually doing is just implementing this this while loop instead of implementing the for loop, which, as you can see, is not ideally for these kind of things. There will be probably 80% of the times you will use a for loop because you wanna iterate through a specific number of elements. But if you don't know exactly the number of elements you want to cycle through, then it's the way you want to use the while loop. And this is exactly why the for loop wasn't behaving in the proper way, whereas the while loop with the exact same amount of lines is behaving exactly how we want. So, but this is of course a pretty simple example. So what if we want to reuse the same for loop or the same while loop without writing 2 times the same code. So this is exactly what we called definitions in Python. So the definitions or functions in Python, you can find again as much as you want, is actually a way to write a piece of code and then reuse the same piece of code in different part of the same script. So we to be able to use this, we need to use the syntax def, the function name, and then the parameters that we want as an input, and then we need to return always a value at the end. So let's see how this works. If we go back to this script, we can just try to convert this into a definition. So how we can do that? So the first thing, we still need the input, output, and the final value. And then what we need to do is just to grab these values here. We can just cut this value, Control X, and then we can define a new definition. So let's go here, and we can say def, which will immediately turn into a predefined syntax. Then we can say range, which is the name, range loop. Remember not to use any specific name related to Python functions. And then we can have between the brackets the parameters. Then we have again the semi-comma, then new line, and we can copy our code. So this code, as you can see, has an issue because the while loop doesn't align with the value of the x. So what we need to do is to select this and then press the tab, and then everything will be right. So the while now aligns with the first line of code, and then whatever is within the while loop is again one tab inside the while loop. And then what we need to provide is actually to return a value. So first thing we need to we have this range array, and the range array is what we are looking for. So what we need to do is to have another local variable, which will be the range, let's say loop is equal to something, and then we return this value as output here, and this one will be range loop dot add x, and the x plus equal steps, and so on. So we need to make some small change to be able to run the script. And what we actually still need are the input variables. So the input variables will be start and step. And there's a slight there's a way to define this variable, and this variable are actually they have a kind of local behavior. So if I call this value like start and step, they are not actually the same start and step, because they are a local variable defined within the function. So whenever we call the function, we can assign to this, let's say, placeholders within the function, the real value. Just to not create for now any kind of confusion, I will call this start definition and definition and step definition. But remember, you can call this the same way you call your inputs. They are not the same value. They are just, this one are just local, whereas these values here are global within this script. So they have a different way of behaving within the script itself. So let's make a small change here. This one is start definition. This one is end definition, and this one is step definition. So we can save this one and then run the script. Of course, nothing happened because we didn't call the function. So we defined the function, but we didn't use the function within the script. And if we go back here, so the function definition is here, the inputs are here, but actually the range array is still an empty array because we didn't really use the range loop functions. So this return range loop will actually return this array, which can then be directly assigned to the variable that calls this range loop. So this piece of code will actually be something much more easier because this can be range loop, and then we assign our variables start and step. Oops. And step. So we call the function. Whenever Python finds this function within the code, we'll just jump into this part of the code. We'll assign this start value to the start definition, this end value to the end definition, and this step to the step definition. We'll go and execute this piece of code, and we'll return an array called range loop, and this range loop will go inside the variable that is calling this function. So we can actually save now and run the script, and this will be the final result. So as you can see, the code is much more clean, and we can call these functions how many times we want. So we can say that this one is range array 1, and we can have range array 2. So range array 1, range array 2, and range array 2 will probably can be, we can just type it manually now. So from 20 to 30, and the step will be, I don't know, 1, something like that. So we can save this one, and the output will just be a list of elements, and we remember how to address these two elements. So if you use the code block, we can use a kind of code block syntax. So list is the name of the variable, and then if we connect this node to this one, the list 0 will be this one, and the list 1 will be this one, which is exactly the same way of using the get item at index, where we can have an index 0, or we can have an index 1. So this is just a more, let's say, design script way of calling the functionalities of the get item index, and it's way more easy and clean. Instead of using multiple of these nodes, we can just say, sorry, we can just say that we want the list 0 and the list 1, and the first one will be the list 0. If we use a watch node, this one is the list 0 and this one is the list 1. So it's a pretty easy way to split lists when they are coming as an output from a Python script. So as you can see, it's very, very, very easy, and you can save a lot of nodes in this way. Whereas if you want to use the, let's say, the node way of calling the get item of index, you need at least 1, 2, 3, 4 nodes, and here you just need one node with 2 lines, and that's it. So it's much more clear. You can also, for example, add some, oops, always the same issue. You can add some comments. So this one can be list 1, and this one can be list 2. And you can always make it much more clean and clear for everyone is coming after you and use the script. Whereas if you want to use this other way, you can still do it, but you probably need to use create nodes and then type something like list 1 or list 2, and then maybe the best way is then to create a group and so on. So it's much more easier, much more clean, and you can embed multiple different operation in the same code block, which is something that we're going to look into more details later. So hopefully now it's a bit more clear how to create definitions. The next step is actually to probably create a library which sits somewhere and which includes different definitions. Because, for example, we can have another definition here, which is add function, for example, or add two numbers. Again, it's very easy, but it's not what I'm looking for now to create very complicated definition. And then we can just return a plus a plus a plus b. So if we want to have this one now, we can just say that sum is equal add two numbers, probably with s here, and then we have, I don't know, we can again use start and end because we already have these two values. So we just modify this one, and this one is sum, for example. So we save this change, and then we have 95.8, which is the sum of the start and end, hopefully. Yeah, it should be. So as you can see, we can embed as much definition as we want, but if we want to create a new script and then reuse the same, we can't really do it because we need to recreate this definition within this script, because the way this definition work is that definitions work is that they work inside this environment only. So if we want to be able to reuse this definition inside other scripts, we need to create what is a package or a library. So to create a library is very, very easy. We just need to create a Python script, which to do it, I'm just going to use the Notepad++. Just create a simple directory, a folder on the C drive or whatever you wanna create it, and then I can call this, for example, functions.py. Let's save it as pi. Yeah, so we can save this, and then as you can imagine, it's way complicated. We just cut this one from here. We go inside here and we paste it. Because this one is has already identified this as a Python script, we already have all the indentation correct, and we just have all the code, color-coded script syntax, and whatever we want to use. So that's the reason why we can still call this one start, end, and step, because this is just a local variable, whereas the other one is a global variable within the script. So To be able to call these functions within your script, we just need to add a very simple piece of code, which is actually very similar to what we are doing here, where we append and we add an external reference. But to be able to add that reference, we need to import a different one. So we first of all need to import the system IO library, just using sys. So import sys will just import the system library. Again, you can Google it, and if you type import sys in Python, so this module provides access to some variable use from the interpreter to interact with actually the operating system. So using this, we can access information about the operating system, we can access folders, we can access input, output, access how to write or read text files and all these kind of things. But most important, we can add a new reference, and we can sys.path.append, and then we just need to add the reference to the folder, which in my case is C / it should be somewhere here. I just need to remember which one is the right one. I can just copy this. Yeah, when I'm using the laptop, it's pretty difficult to get the right keyboard, because I have a different keyboard, and I'm using the Australian language, but with different keyboard. So anyway, doing that, we just need to use this R before this path, just because we are using a Windows system. Otherwise, we need to use the \. But because I'm usually copying the path from directly from the folder, we just need to add this R before this sys append. So once we have imported our function, or better, we added this path to the library, then we can import functions, for example, as f. So this is another way to import libraries. So in this way, I'm just saying import whatever is in the functions and use let's say a placeholder name as f. So if we want to use the range loop, we just use f dot range loop, or f dot add two numbers. Save this one, let's run this, and then let's see which one is so we import function.py, and in line 5 we have an error. So the list object has no attribute add. What does that mean? Let's go here. There should be we probably need to use append. Line 5, why it's not working? Oops. Yeah, there should be something wrong with this line 5. I already saved this one, and I can go here and save the changes and run again. Let me try to do something different. Let's first of all, let's remove this one for now. Let's make sure that this is working with one of the function. We can also use from functions import. Where is this? I need to copy and paste this. And then we can say range loop. There are different ways to identify, but still we have the same issue. So on line 23, range loop start end step, which is okay, so it should work. Why it's not working? So let's save as this one. Yeah. Let me close this one. And probably let me do something like this. Save function and run. Doesn't like it. It's always like that. You try to do the things live and they don't work. So import functions. And not with capital, sorry. And then as F. This one it just doesn't like it. F dot start and step. And why not? Again, sometimes it's really funny. So Python lib open. Range loop, save, and close, and go back to here. It's just really funny that doesn't work. Just worked before. So let me Control X, run, and save. Still remembers, okay, the previous one. Again, save and run, and that's fine. Now it works. So sometimes really it's just a syntax error which will not make the things function. Yeah, today it's a bit annoying, but that's okay. Let me go back here. It's always good to have errors. So as we can see again, I didn't use anymore the add functions, which is something that it's working within Dynamo, but is not let's say a Python proper way of adding elements to an array. So I had to change it into append, but I managed to use the capital A, which is not the right syntax. So we need to use append, and but finally I finally managed to do it. So now if I go back here, I can also so I import the function as f, which is the now is kind of placeholder for the functions within this library, and I can again now call the sum is equal to f dot sum, add two numbers, and then start end, and then I can just have this one as an output, which is what I was expecting. The same thing I can do here. I just need to, because I'm lazy, just need to copy these 2 lines into this script, and then I can just use now, for example, sum equal to f dot add 2 numbers 10 and 20, and then have this value here, sum, and then if I run this script now, import sys, sorry, here, then save the changes, and I need an S here, save the changes, and this one just works. We don't need any input because we are brute forcing the values inside. So this one is 2, for example. That's it. So this is working pretty good. And the good thing is that if we go back here and we add a new function, which will be, for example, multiply 2 numbers. I just need to find, I just don't know how to do it on the keyboard. There's always a way to do it. And we can save this one now. And if we go back here without touching anything, we can do multiply is equal f dot multiply 2 numbers, again start end, and we can do mult here, save, run, and this one will work. So we didn't touch anything in the code, we just add a new function to the library, and as soon as we save that function in the library, we can start to use it within our scripts. So you can just imagine how much interesting can be this the way of creating outside this library. So I think I don't want to force too much onto these things. I just want you to understand and just go back and rewatch the video. Again, I do apologize for the many errors, but it's interesting that at the end we can try to understand what kind of error you can occur into as well, and we kind of fix that errors. So going back, we did manage to create a range. We understood the way of creating ranges using the for and the while loop. And we kind of understood that, for example, the range is better to be created as a while compared to what we can do with the for loop. But again, we will use the for loop many times compared to how many times we're going to use the while loop. But it's another thing is that the while loop works with the float numbers compared to the for loop, which doesn't work with float numbers. Then we kind of create the first definition, and then after we create the first definition, we create an external file, which is actually a library. And this library was using this library, we were able to list a bunch of different functions and start to create our own library. You can create multiple libraries, so they don't have to be always in the same file. The way you interact with different libraries is pretty easy. So you can, if the libraries are always in the same path on the system, you use only once this specific line, and then you can just import other libraries. As I don't know, you can use L, or you can use whatever name you want to use. You can also import specific functions from a specific library. So if the library is very huge, sometime you don't want to import all the functions from that library, you just want to use some specific one. So you can do that using, let's keep this one as it is. Actually, I don't want to do this one. So let's run. So for example, in this one, we're just using the add two numbers. So I can say something like from functions import, instead of using the star, which will import all the libraries, we just import the add two numbers. Then we don't need to use this F here, we just use directly the add two numbers. And this one will do the trick. Whereas if we want to do a multiply, for example, is equal to multiply two numbers, and then we say again 10 and 10, and we add this one to here. We save the change, we run the script. This one will not work because the multiply two numbers is not defined. So to be able to use it, we just need to import that function as well. Multiply two numbers, and then save the change, run the script, and this will work. So of course, for this very small library, this doesn't make sense. We can just import all of them. But for very big libraries, very huge libraries, you can just import the functions that you need, the specific function that you need, if you know the names, and then you can reduce the amount of time that Python will just spend to import all the functions if you don't really need it. So if you want to make your code a bit more faster, you just want to make it a bit more consistent, so you know exactly which functions you want to implement, and you can just import that function. So then you don't even need to use the, let's say, placeholder for the library like we were using in the previous code, like this one. So this one is actually used whenever you want to import all the functions, all the functions from the libraries, which for now are just functions, but we will see how to import classes as well and how to create classes as well. So I think for today we can call the day for now, and I leave it with you to try to implement some specific function to do some interesting mathematical equations or whatever you want to need to implement. We will use again functions to create, for example, geometries, or to create any other kind of interesting stuff we're going to do. So thanks for now. I'll close this one, and I'll see you next time.